Hello everyone and welcome to another video. In this video we are going to discuss about mathematical expectation. Now that we are clear what is a random variable, we can understand the concept of mathematical expectation. So let's say here x is your random variable. In short, we write random variable as RV and P are the respective probabilities of these random variables. Now, mathematical expectation is actually defined as summation of Pi xi, that is x1 P1 plus x2 P2 and so on till xn Pn. This is defined as a mathematical expectation when it is in discrete form. So whenever your random variable is discrete, the mathematical expectation is defined as this. In case your random variable is continuous, in that case mathematical expectation is defined as integration of the PDF of the random variable into x variable, right? And the limit goes from a to b. We will discuss this in example. Now, let's say we need to define the expectation of x to the power 4. So, expectation of x to the power 4 is nothing but summation of xi to the power 4 into pi, which will look something like this, that is x1 to the power 4 p1 plus x2 to the power p2 into p2 and so on xn to the power 4 into pn. And on the similar lines for a continuous distribution, it will be defined as integration PDF into x to the power 4 dx. Moving ahead, just as we defined expectation of x to the power 4, we can actually generalize this for any function of x. So, expectation of g of x, where g of x is nothing but a simple function of x. So, it will be defined as summation of gxi into pi. And for continuous distribution, it will be in the form of integration of gx into fx, where fx is the PDF. Now, let us discuss this question to get a better understanding. Let's say there is a discrete distribution which is defined as given. So, the value of x1 is minus 1, x2 is 0 and x3 is 2. So, we need to find out what is the value of expectation of x square. So, expectation of x square is equal to x1 whole square into p1 plus x2 whole square into p2 plus x3 whole square into p3, which is here. Now that we have got the understanding of what is expectation, let us discuss about properties of expectation. Now let's say a function of x is defined as this, which is y is equal to ax plus b. Now, expectation of y will be nothing but a into expectation. Okay. Now, expectation of y will be nothing but expectation of ax plus b. So, we can take a out of the expectation. A expectation of x plus b. So, this will be your expectation of y. Let us see one example. If if expectation of x is equal to 3, then find the expectation of 2x minus 7, which will be defined as so this will be your expectation of 2x minus 7. Now, one thing to note here is that the expectation thus depends upon both change of scale and origin. So this becomes your change of origin and this becomes the change of your scale, and we see that expectation is affected by both. Moving ahead, consider two random variables, x and y. So in such a case, what will be the expectation of x plus y? So expectation of x plus y is nothing but as simple as this. And expectation of x minus y is equal to expectation of y minus expectation of x. I hope you got this correct. Now, let us discuss the next property, which is if the value of x is greater than 0. That is, if all the x values are positive, right? So in that case, expectation will also be positive, because we know that expectation is nothing but summation of pi into xi. Now, since xi is always greater than 0 and probability also is always greater than equal to 0, probability is never negative. Hence, expectation of x will always be greater than 0. However, the converse of it is not true. You might get expectation as a positive value, but we cannot say that xi's were always greater than 0, right? Next up, we define certain ranges and we say that if x lies between a value a and a value b, then it is sure that the expectation will also lie within that range itself. However, the converse of it is not true. Moving ahead, if x is greater than equal to y, it implies that expectation of x is also greater than expectation of y. However, the converse of it is not true. Next up, we say if expectation, we say that expectation of mod of x is always greater than mod of expectation of x. Now, for these two, we will discuss in detail why this is happening. Let's go down and understand that. So, in the cases where your g of x, particularly if I talk about mod of x, so your g of x is mod of x in this case, okay? Now, if double derivative value, if the double derivative value of, now if the double derivation Now, if the second derivative value is greater than equal to 0, then such function is known as convex function, and expectation of g of x will always be greater than g of expectation of x. Consider that your g of x is x square. So its first derivative will be 2x and second derivative will be 2, which is greater than equal to 0. Hence, x square is a convex function, and therefore expectation of x square will be greater than whole square of the expectation of x. And if we have a concave function, that is, we get the double derivative value less than 0, then in such a case the sign is opposite. So it becomes less than equal to g of expectation of x. That is all for this video. Thank you for watching. If you have any questions, please post them in the comment section below. Thank you for watching.